All right, we're doing 9-3, which is on the transformation reflection. I am on page 112 in the Springboard book. So you read the problem and you've got this rectangle here. I think it's marching band. And at first glance, if you just glance at this and you say, oh, I want to move this rectangle to down here, you might jump to the conclusion that it is a translation because one, that's what we've been working on. But if you do this translation, if we take this and we slide it down, oh gosh, I don't know, it'd need to slide down how many? 1, 2, 12 places. If we did slide this rectangle down 12 places, then you notice that it didn't come out exactly like the band director wanted it to. What's wrong? This person right here is in the wrong place. So we're going to have to do something different. And what we do here to actually get this rectangle transformed into this rectangle, we have to do a reflection. And it says right here that reflections are sometimes called flips because the figure is flipped like a pancake. I'm going to go to another screen right quick to explain to you what this means. I'll make sure that you get the link to this little activity so that you can go here and play with it because I think it's really helpful. All right, so we're in GeoGebra, and this picture right here is what is marked. You unclick that and it goes away. You click it again and it comes back. And then this is the reflection line. Everything on here can be moved. So if you want to see what it would look like to do a rectangle the same size that was on the other one, you could just move these things until your rectangle matched. And I don't think this one's the same size. So you could pull it down and make it be the same size. But anyway, I'm using too much time. You get the idea. You can also move this line, okay? And once you get this line moved, you can then click the reflection, and this shape, the original, will reflect over that line and show you where the new coordinates are. Now, I want to show you real quick what these coordinates are because this is going to help make clearer what the Springboard was trying to say. And I'll flip back over there in just a second. So this original graph, this point D right here was at 3, 2, and I probably need to change color because I know some people are having a hard time seeing. 3, 2. Okay, and D prime ended up being at 3, -2. So what changed? Well, the X value stayed the same. The Y value, which was a 2, became a -2. Okay, so the point XY transformed into what point? The X stayed the same and the Y became negative. That's what Springboard was saying in this section right down here. It says on the coordinate plane, examples of reflection are defined by functions, and this is the function x comma y. Any point xy will map to, this one says -xy because it's reflected over the y-axis. I'll show you that in just a second. And then this one's talking about x comma y or maps to or moves to x comma negative y, which is reflection over the x-axis. All right, and then this one right here, and I'll show you both of those. So let me go back over here and I'll show you both of those. So this is what it looks like when reflected over the x-axis. Okay. To make it reflect over the y-axis, what do? You put this line. And if you don't want to see the shape actually move, you can turn the reflection off. I gotta get my line really straight. And then you can reflect it, and it's going to show you that D was at 3 comma 2, and then after we reflected it over the y-axis, it became negative 3 comma 2. Because when it changes from one side of the y-axis to the other, on one side of the y-axis, the x values are positive. On the other side of the y-axis, the x values are negative. So if we have a different line of reflection, our point changes by changing the values of the signs of the x values, and the y's stay the same. Remember, this is if we have a reflection, and I'll have to look what the notation is. I can't remember if the notation is a capital R or lowercase r, but there is notation, and we'll go over that, I'm sure, in one of the videos. But this is if you're reflecting over x, over the x-axis. Then we say the y values change. And if we reflect over the y-axis, this is over the y-axis, then we say the x values change signs. Okay, now the last one that they were talking about, I'm going to hide the reflection. They were talking about the y equals x line. So I'm going to graph the y equals x line. I'm also going to move these points just to make it come out to be really nice. Oh, let's make it be a rectangle this way. Okay. My D value is no longer at 3, 2 though. So that's changed. We can erase this and this. My D value, and it doesn't matter, you can pick any one of the points. My D value this time is 3 comma 4. The D value is 3 comma 4. And reflect it over the line, and D prime becomes 4 comma 3. Oh, good grief. 4 comma 3. And you can go back and check all of these other ones. C is negative 1, 4, and C prime is 4, negative 1. E is 3, 6, and E prime is 6, 3. So when it's over the y equals x line, the transformation that takes place, or the changes in the points start off being the point xy. Then what did it become? It became the point y comma x. You might remember that from Algebra 1. You did a little bit of transformations or reflections over the y equals x line, because those are called inverses of each other. And if you didn't, you will certainly do it in Algebra 2. So reflection over the y equals x line causes this change in the point values. It doesn't hurt to have this memorized, you guys. Some of you will be able to think your way through it just by kind of visualizing the reflection taking place. These are pretty reflection over the x-axis, reflection over the y-axis, and reflection over the y equals x line is pretty easy to visualize. But if it's not, please come here and play with some of these things. And all you have to do to reset everything is just click that little button right there. And if my markings were erased, you would see it is back where it started off to begin with. Okay, there is another one right over here, reflection of an object. And this one is very similar. I don't think that you can turn the images off here. This is you, and it doesn't matter which one you consider the original. This is the pre-image, and this is the image, or vice versa. It doesn't matter. But what you can do is you can change. Okay, you can change this, and as you change this, this changes. And you can also move your line of reflection. So there's across the x-axis, here's across the y-axis, and here's across the y equals x line. So this is another one that you can play with. I like both of them. I like this one because you can turn off all of it. You can have a blank screen and you turn them back on, but you can still make changes. And so I like this one because you can put they call it a mirror line, because this line acts like a mirror. And you can, before you turn the reflection on, you can estimate where it'll go. And then you can check yourself. And this one is really more for, this one is really more for kind of getting a visualization of what happens. You can, see what it looks like. And you can also check the ordered pairs and see, does that rule that I learned hold here? So anyway, so I will make sure that you have the link to this set of stuff. It's got some other really cool stuff. I'm going to use this a little later on in another one of our videos, but feel free to play with it. Okay.